All right, today we're going to dive into distributed ledgers. Now, if you're already comfortable with how traditional databases work, you're in the perfect spot to understand this next leap. We're going to ask, what happens when you build a database that doesn't have a single owner, one with no central point of control at all? Let's get into it.
So, this whole thing really kicks off with one big question. I mean, we're all used to trusting our databases because we trust the company or the people running them, right? But what if a database could be trustworthy all on its own, with no administrator needed? That one idea, that single question, is the key to this entire technology.
Okay, so first things first, let's build a new foundation here, moving from that familiar idea of a database over to this concept of a distributed ledger.
So you might be thinking, is a distributed ledger just a fancy new name for a decentralized database? Is it really that simple, or is there something more going on here?
Well, the answer is kinda yes and no. At its core, a distributed ledger is a decentralized database. Every computer in the network has its own identical copy. But it's probably more helpful to think of it as a super sophisticated shared accounting book. And this idea of a shared verifiable record isn't new at all. Double-entry bookkeeping has been around since the 15th century. DLT is just the next big step in that evolution, but for our digital world.
And this is really the key difference, right? It's a fundamental shift in control. A traditional database is like a monarchy. There's one central server that rules over everything. A distributed ledger, on the other hand, is more like a co-op. It's a peer-to-peer network where everyone involved collectively maintains the ledger. No single person or company is in charge.
Okay, that brings us to our next big topic. Let's look at how this different philosophy leads to a completely different architecture for storing and securing all that data.
We all get the client-server model. It's predictable. A client asks for something, a central server gives it. It's a one-way street, basically. So how does this whole peer-to-peer ledger thing totally flip the script on that?
Well, it all comes down to the role that each participant plays. In the old model, you have a clear divide. Clients are takers, servers are givers. But in a peer-to-peer network, every single participant, every peer, is both a consumer and a supplier. They all talk to each other directly, sharing and validating data without any central middleman.
Okay, but wait a second. That brings up a huge red flag, doesn't it? If there's no central admin checking all the work, what's to stop someone from cheating? From spending the same digital money twice? It's called the double spending problem, and it's a massive hurdle for any decentralized system. So how do you keep things honest?
And the solution is pretty brilliant, actually. The network itself becomes the authority. Instead of one gatekeeper, every single transaction goes through a three-step dance. First, it gets broadcast to everybody. Second, all those participants work together to agree, to reach a consensus that the transaction is legit. And third, once it's verified, it gets locked into the ledger for good. Because the whole network publicly signs off on it, double spending becomes pretty much impossible.
So, we've got the how. Now let's get into this so what. Why does any of this actually matter? What are the real payoffs of building things this way?
I get it. The tech is cool. But what does that mean in the real world? What are the actual, tangible benefits of organizing our data like this?
It really comes down to three huge advantages, and they all spring directly from that decentralized design. You get redundancy, which makes the system incredibly resilient. You get immutability, which builds trust. And you get transparency, which creates accountability.
Okay, let's stick with that second one for a minute. Immutability. That's a strong word. What does that really mean for a record once it's been put on the ledger?
It means exactly what it sounds like. It is set in stone. Once a transaction gets verified and added to the chain, it is locked in forever. Nobody, and I mean nobody, can go back and alter or delete it. This creates a permanent, tamper-proof audit trail. And that is the foundation of trust in a system. You don't have to trust an administrator because you can trust the record itself.
Right, but that brings up another potential problem. Transparency. If every participant can see the ledger, what happens to confidentiality? I mean, businesses can't just have all their transaction details, like who they're paying or what prices they're getting, out in the open for competitors to see. Doesn't this create a huge privacy issue?
And that's a super important point. Transparency here doesn't mean your company's secrets are blasted out to the whole world. It just means all the approved participants in a network see the same version of the truth. You can have public, permissionless blockchains like Bitcoin where anyone can join. But for businesses, you have private, permissioned blockchains. Think of them like a corporate intranet. Access is totally restricted, which lets companies get all the benefits of a shared, trusted ledger while still keeping things private.
All right, let's bring this all home in our last section. Let's connect all these ideas to understand the ultimate payoff of this technology, getting rid of that central bottleneck.
So when you spread that ledger out across a whole network, you get two massive payoffs. First, you get rid of the single point of failure. There's no central server to hack, no single system that can crash and take everything down with it. The network is resilient. And second, and this is the big one, you get rid of the need for a lot of traditional middlemen. Trust is baked right into the system's rules, not handed down by some third party.
Just think about a simple credit card payment, right? You swipe your card, and that transaction has to bounce between the merchant, their bank, the card network, your bank. There's this whole long chain of middlemen, and every single one takes a cut and slows things down. With a distributed ledger, that payment can go directly from the payer to the payee through the peer-to-peer network. You cut out that whole institutional chain, and the process becomes way faster, way cheaper, and way more efficient.
And this quote from Satoshi Nakamoto, the creator of Bitcoin, really gets to the heart of why this was invented in the first place. The problem with the old way is that you have to trust a central authority, a mint, a bank, whatever. The fate of the entire system rests on their shoulders. The whole goal of DLT was to build a system that didn't have to depend on one central, fallible institution.
And that leaves us with a really big question to chew on. The entire idea here is about shifting from institutional trust to technological trust. So, if we can really build that trust directly into our code, you have to ask, what other middlemen in finance and maybe everywhere else do we just not need anymore?
And there you have it. A quick tour of distributed ledgers. I really hope this explainer helped make the core ideas a little clearer. If you found it useful, do me a favor and hit that like button, share it with someone you think might be interested, and of course, subscribe for more explainers just like this one. Thanks for watching.